Hi, and welcome to Module 11. In this module, we'll explore the death of stars.
That's his module, the death of stars.
This is an image of Cassiopeia A.
Cassiopeia A is a supernova remnant, the classic example of the death phase of large massive stars. There was once a star in the center. It exploded and blew all its gas components concentrically outward 360 degrees, generating pulsars and radio waves as it moves through space. An explosion during which a star suddenly increases its brightness over 1,000,000-fold, which are intermediate and high mass stars. They violently blow apart in supernova explosions. Small stars like our sun are not large enough to explode as supernovas. What we see here is the recording of an actual supernova event. On the left-hand side is a picture of the night sky, say January 1, and you see a star. That's 200 million light years away. So that means the light has taken 200 million years to reach us. And on the right-hand side, you see a photograph with the same telescope taken the very next night showing an explosion. So what we see is that 200 million light years plus 1 day, and we see the remnants of a star that no longer exists.
Supernova remnant is the nebula left over after a supernova detonates.
The Crab Nebula is the most famous supernova remnant because it was actually recorded to occur by the Chinese astronomers, and it turned night into day. When evening came, the sky still remained bright for multiple numbers of days. And they had no way to explain this except that it meant the god said the emperor was good and they didn't get killed. And and again, supernova remnants give out radio waves and pulsars as they explode. Here we see another supernova remnant called the Gum Nebula. We're only seeing the central portion, but you can see that it's a concentrically exploded outward explosion, and the gas is moving at the speed of light in all directions, to where now the remnant remains of this star now is approximately 300 light years across. Here is the Veil Nebula. What we see here is just a small portion of the bigger part of the Veil Nebula that's over here. But we can tell that this is a characteristic feature of a shock wave from a supernova explosion. Here's the exploded Ring Nebula. Star in the center, gases exploding concentrically outward. Another view of the Ring Nebula taken in infrared wavelength. This is an image of a white dwarf star. White dwarfs and pulsars are two death stages of stars. They're the collapsed stars from intermediate and low main sequence stars like our sun. Here we see a star that is exploding apart in two directions, concentrically, with hydrogen emissions on the left and the right. And here we see a star that has broken itself in two and is exploding outwards. We can tell that by the shock waves. Look here, the shock wave is going this way, the shock wave is going this way, and this way, and this way. That means it's split down the middle and blew sideways. This is an image of a supernova remnant in multiple wavelengths. And again, remember from spectroscopy, color allows us to determine the chemical composition of the objects in space. This is perhaps the most famous supernova remnant discovered by Tycho Brahe many centuries ago, and it's quite beautiful. Again, a concentric exploded star. You can see that it is not a nebula. So in this module, we learned about star properties, the death of stars, supernovas, the white dwarf phase, and the interstellar gas remnants.